Okay. Get my ladybug on. Sarah Shuck, what is your favorite multiplication fact?
7 times 2.
What was that?
7 times 2
Give me the whole thing.
equals 14.
Okay. So this is what we're starting with today. We have Sarah's favorite fact, 7 times 2 equals 14. Today's lesson is practicing factors again. So we're going to go ahead and label this with what we know. Maria, pick some part of this equation and tell me the math words, the vocabulary words that we know are represented by these numbers. So do you know what we like? Okay, so we've been talking about some vocabulary words. Instead of saying the numbers that we're multiplying and the answer, we have actual names for those things. Julian, help her out.
Factors.
Which numbers, Julian, in this equation are the factors?
7 and 2.
Okay, so keep yourself unmuted. So Julian, we could say, what would a definition be for the word factors? Those are the numbers that were what? What are we doing with these numbers?
Multiplying them.
Very good. So I'm going to put a little definition here. The numbers we are multiplying. Okay, Julian, do you know what the answer to a multiplication equation is called? There's a fancy math name for the answer to a multiplication equation. Anyone remember? Colin?
Product.
Very good. So I'm going to label this the product. And I'm going to put the product is the answer to a multiplication equation.
Miss Shevchik.
Yeah.
I just thought of something. I don't know what it clicked in my head, but maybe somebody has said this before. So the two factors of the equation equal the product, right? So in a factory, you make the product, right? I mean, that's a way to remember it.
It is.
God, only if I use my head like it's in school.
Yeah, we'll put that in highlighter. The factory makes the product. Factory makes the product. Okay, so I have some more questions about this. So if I want to know, if I said, is 2 a factor of 14? What would you put in your calculator to tell you if 2 is a factor of 14? What do we put in the calculator? Maria?
2 divided by 4.
Now look at my calculator, Maria. Does this tell me if it's a factor of 14?
Oh, I meant 14, sorry.
Okay,
divided by
think about what number you want to start with. Do you want to start with the factor or do you want to start with the product?
Oh, the product.
Right, you always want to start with the big number. So this is number. We want to see if 2 is a factor of this number. So we put that number in here and I divide by 2. And what do I get, Maria?
7.
Is this a whole number or a decimal?
A whole number.
Very good. So that tells us that yes, it is a factor. But then look, we also can say that 2 is also a factor of 14 because multiplication has that commutative property where we can switch the numbers around and still have the same answer. Now this one's a little bit off. So I want you to tell me if I try to divide 14, if I want to see if 3 is a factor. Let's see, let's have Izzy. Is 3 a factor of 14?
No,
How can you tell by using my calculator?
it's because there is a decimal.
Right, so when I still use 14. If I was investigating to see if 3 worked, I got a decimal. Is a decimal, Izzy, a whole number?
No, it's not a whole number.
So can you explain what is a decimal then? If I know a whole number is a whole piece, like a whole candy bar, what is a decimal? If it's not a whole, what could it be?
Half?
Okay, so that would be like a piece of something, right?
Yeah.
So is a half of a candy bar the whole thing?
No.
No, it's a piece of it. So if you look at this, we would have 4 whole groups, but then we have some left over that doesn't make a whole group. So we have some left over or we have a piece of something. So that's what I mean whenever I've been saying we have whole numbers and decimals. Okay, so I just wanted to do that little review before we got started today on our problems. So now you have a page that if you came to our Zoom yesterday, we zipped through these. And if you did them on your own and watched the Zoom, you saw how well we went through these. Now, we're going to do something in a little bit of a different order today. So we're going to start with letter E. So go to letter E in your book. What does letter E say, Riley?
Is 6 a factor of 72?
Okay, now hopefully I'm going to try to help explain some things to you by doing this in an out of order. So I have the number, we're going to investigate to see if 6 is a factor of 72. But right here, I want to take the number 6 and I want to see what I can multiply to get 6. So what are some other factors of 6, Noah? Other than 6 times 1, what else can you multiply together to get 6?
You could do 4 times 2.
That gives me 8.
I mean, 6 times 1. I mean,
All right,
1
other
times 6.
Right, I don't want to do the 1 rule. We're going to leave the 1 out because we get itself. But what else can you multiply together to get 6? There's something else and it's not 1.
2 times 3.
Very good. So right here, I want you to write 2 times 3 off to the side. So we know that we can multiply 2 times 3 or 3 times 2 to get 6. Keep that in mind for later. So just tuck that off to the side. So now I have my calculator. Noah, if I want to see if 6 is a factor of 72, what would I put in my calculator?
You will put 2 times 6. I mean, 2 divided by 6.
Basically, we want to figure out if 6 times anything would give us 72.
6 divided by 2.
No, because 6 divided, you're not using, you have to use the numbers in the equation. So
6 divided
no,
by 7.
just listen. No, you're just spitting out numbers. Just listen for a minute. So this question right here, is 6 a factor of 72? This is just like saying, can we get anything to work with 6 times something equals 72? So there's 2 things that you can do. You could take out your multiplication chart and look down the list of 6s and see if you ever find 72. But you can also use your calculator. Noah, what's the opposite of multiplication? What operation?
Division.
So when you divide, what number do you always have to start with? The smaller number or the bigger number?
Bigger.
Okay, so I'm going to take my 72. I'm going to put that in my calculator. And I'm going to divide by the number that we have here. So I'm going to put divided by 6 and see what we get. What's the answer?
6.
No. 72 divided by 6.
72 divided by 6.
Are you typing it in your calculator?
$12.
Is 12, I have it up here on my screen too. Is that a whole number? Or do we have a
Yeah.
decimal? Okay.
No,
No, there's no dot, there's no points. So this is a decimal looks like this. Do you see how it's like 10 dots and all those numbers?
Mhm.
This is not a whole number. But if I put this in my calculator and I get a number without a period, that's a whole number. So I'm going to write that down for in my box. Now, Noah, look back here. We know that 72 divided by 6 equals 12. So what can you multiply 6 by to get 72?
72.
6 times 72. No, that gives us too big. Use this to help you. Because remember, multiplication and division are opposites. This is, we could make a fact triangle.
12 divided by 72? No.
So in this fact triangle, if I have an answer of 72, I can multiply, or I can do 72 divided by 6 gives me what?
It gives you 12.
Okay, so we can, so then, Noah, can you see my triangle?
Yeah.
Okay, so this is a family. So 72 divided by 6 equals 12. 72 divided by 12 equals 6. Now we can do the multiplication. 6 times 12 equals 72, and 12 times 6 equals 72. So all these numbers are related. So now look back at what we started with. 6 times what gives us 72?
6 times 6 times
Use
6
this triangle to help.
6 times 12.
6 times 12. So I could put a 12 where my question mark is. So Noah, is 6 a factor of 72?
Yes.
Yes, because I can multiply 6 by 12 to get 72. And then we're going to use this as our proof. So Riley, looking at this, all the work we did, we know that what else, other than 6, what else is also a factor of 72?
12.
12. Yep, because we can multiply 12 by 6. So the partners are also a factor. Very good. Okay, Colin, go ahead and unmute yourself. Okay, so do you remember yesterday when we did the problems that looked like this?
Yeah.
So that was telling us basically that when you use the associative property, which is using different combinations to make a number, that any of the numbers that you multiply to get those factors are also factors of a number. So right here, we saw what can you multiply? What other factor can you get to equal 6 other than 6 times 1?
2 times 3.
Okay, so look above now. We just solved and we found out that 6, yes, indeed, is a factor of 72. Maria, do you have a question?
No, I don't know. I accidentally pressed it. Sorry.
Okay, so we see right here. Now this, zone in for a minute, guys, because this is gonna help you with number two, I think it's number 2 on your exit ticket. We had a lot of questions in school about this. We said yes, 6 is a factor of 72. Both A and C also are asking if numbers are factors of 72. They're asking if 2 is and if 3 is. But look right here. Move your heads. We said that 2 times 3 gave us 6. So if this rule works, because 6 is a factor of 72, and I multiply 3 times 2 to get 6, then Colin, what should be the answer to these, to A and C? Yes or no?
Yes.
It should be yes if you follow the rule. So now let's investigate and see if it's true. Let's see. I haven't talked to Sophia. What do I put in my calculator to test to see if 3 is a factor of 72?
You're gonna do 72 divided by 3.
Equals what?
24.
So is 3 a factor of 72?
Yes, it is.
Yes. And then you have 2 different options to put for your proof. You can put, because 72 divided by 3 equals 24. Or you can put 3 times 24 equals 72. Both of these prove that 3 can be multiplied by something to get 72. I would write both of these down for now, so we start to really just get the hang of these. So far, this little trick worked. 3 indeed is a factor of 72. Now let's see if 2 works. Tanya, what would I put in my calculator to see if 2 is a factor of 72?
72 divided by 2.
And what do you get for your answer?
36.
I blocked it. So is 2 a factor of 72?
Yes.
Yes. What's my proof, Tanya?
72 divided by 2 equals 36.
Tanya, can you also show me what can I multiply 2 by to get 72?
2 times 36 equals 72.
Very good. So you see, we're using these fact families for all of these questions. Okay, here's a bonus question. Who can give me a different reason why you know 2 is a factor of 72? Think about it. I'm going to go turn off this one set of lights so the glare's gone. Anyone think they know? And this only works with 2s. Anyone have a reason why they knew this was yes before we used the calculator? Nevaeh.
Because 72 is even.
And what do we know about even numbers and a number 2?
It will always.
Be a what?
Be a fact.
There you go. 2 is always a factor of an even number. All right, I want you to repeat after me. 2
Will
is
always
always a factor of an even number.
of an even number.
All right, I saw some of your mouths moving. I want someone at your house to say, what are you yelling about? And then you can tell them. 2.
2.
Brian, 2 is a what?
An even factor.
Come on, Noah, give
Always
Brian
an even factor.
Noah, mute yourself. Noah, mute yourself. Brian, unmute. Tell me, Brian. 2.
An even.
Well, you gotta use the word always. This is like cheerleading practice. 2 is what?
Always.
Always what?
A factor of an even number.
All right. Okay, so the A, C, and E, revisit this problem when you're doing your exit ticket if you're having trouble with number 2. All right, let's move on to letter G, Bella. Is 5 a factor of 72? Before you use your calculator, do you have an answer to this? Is 5 a factor of 72? Unmute yourself for a minute, Bella.
It says 8. It's not.
Who is your kindergarten teacher?
My kindergarten teacher?
Uh-huh.
I didn't go to Nicely when I was in kindergarten, so I can't
where'd
really
you go?
remember.
All right. You remember Miss Cribs? Do you have Miss Cribs in 2nd grade?
She was a mean teacher, too.
You remember anything about kindergarten?
No.
All right. Stuff, I'll come back. Who remembers anything from kindergarten? Anyone?
I wasn't here when I was in kindergarten.
I know Tessa will remember. Tessa, unmute yourself.
Yeah.
Who was your kindergarten teacher?
Miss Bishop.
Well, I know Miss Bishop knew this. Do you remember counting by 5s? in
Oh,
kindergarten?
yeah.
Count by 5s for me. Go.
5, 10, 15, 20, 25, 30, 35, 40, 45, 50.
For those of you who were listening to Tessa, she's going to do that again, but this time I want you to listen to, as she's counting by 5s, every single number that she says only has 2 different numbers rotating back and forth in the ones place. Go ahead again, Tessa, a little bit slower.
5, 10, 15, 20, 25, 30, 35, 40.
Ryan, what did you notice? What do we rotate back and forth between in the ones place?
Even and odd.
Well, that is true. Tessa, do it one more time. Brian, I'm going to make the number in the ones place as she's reading. Go, Tessa.
5, 10, 15, 20, 25, 30, 35,
5
40.
and 0.
Very good. When you count by 5s, it's always going to end in a 5 or a 0. So Tessa, does 72 end in 5 or a 0?
No.
So we can predict that is 5 going to be a factor of 72?
No.
I think so. I don't think so either, because it would have to be 70 or 75. Let's check with your calculators. 72 divided by 5. Tell me what you get.
I got 14.4.
So Tessa, is 5 a factor of 72?
No.
So we're going to put 72 divided by 5 equals 14.4. 14.4 is not a whole number. So basically that's telling you that there's nothing 5 times, there's nothing you can multiply 5 by that's a whole number to get 72. No facts. 5 times 1, times 2, times 3, nothing will work. That's why 5 is not a factor of 72. Okay, we're going to, any questions about those? If you have a question, go ahead and unmute yourself. Looks like some people are still writing. So I'm gonna leave this up here while you're writing. If you're ready to move on, I want you to turn to page 117.
What page?
117. Tyler, Carson, and if you guys are coming to class today, please put your cameras on or else it won't count for your attendance, please.
Did you say we had to go on page 117?
Yes, ma'am. Okay, we're gonna do number 2, and that's gonna be the last one we do today. Number 2 is just like what I showed you, and we're gonna look at this associative property again. And this is just showing you how you can find more factors of a number. Carson, are you there? Carson? Anyone home? So what we're going to do is we're going to show how breaking down one of the factors of a number can give us more factors of that number. Okay, who haven't I talked to yet today? Carson, but he's not answering me. Nina, read the equation for letter A, please.
12 equals 6 times 2.
So Nina, we know that so far, just looking at that equation, what are some factors of 12?
There's 6 times 2.
Okay, so 6 and 2. No, that's all you know from there. 6 and 2 and 2 and 6. Now, Nina, we're going to break down this equation to show you more factors. So right here, this 2 is just hanging out over there. We're going to take this 6 and break it down into something times 2. So what can I multiply 2 by to get 6?
3.
Okay, now Nina, let's check and make sure this still equals 12. What's 3 times 2?
6.
And remember, these parentheses should be waving to like arms, waving up and down saying, do this first, do this first, telling you. So 3 times 2 equals 6. And then Nina, what's 6 times 2?
6 times 2 equals 12.
Very good. And that's what we have as our answer. So Nina, looking at the equation that you just solved, what else? Carson, why don't you try to log off and log back on? I don't know. Oh, he must have tried it. Okay, so now we're going to move the parentheses. So instead of there being parentheses around 3 times 2, Tyler, we moved them and just put them around 2 times 2. So what's the only thing left to bring down from the previous line? Tyler?
3 times 2.
Well, we already have, there are only 1 numbers. What goes on this line? We already brought down this 2. We brought down this 2. What's left to bring down?
3.
Now, all we're going to do is we're going to see, Tyler, if moving the parentheses matters. On this line right here, what are we going to do first? What's waving? Do me first.
2 times 2.
What is 2 times 2?
4.
Now, let's take your 4 and multiply it by 3.
4 times 3 is 12.
Okay, so Maria, we know that 2 and 3 are factors, 2 and 6 are factors of 12. What other number here can we include in our factor list?
The 12.
No, we don't have any 12s over here.
Oh.
I already highlighted 6, 6, and 2. All this work we did, we broke down all these numbers, and there's one new number that's not included up here. What's the new number?
4.
There is no 4 here. There's 3, 2, 2, 3, 2, 2. We already have 2 highlighted. What's the new number?
Oh, 6.
There is no 6. There's a 3, a 2, a 2, a 3, a 2, a 2. I already have 6 and 2 highlighted. What's the new number?
3.
There you go. So 3 is also a factor because when we break down 6, we get 3 and 2. So now down here, we're going to bring our 3 down. What is 2 times 2, Tyler?
3 times 2.
2 times 2.
2 times 2 is 4.
Okay, Carissa, now I want you to look at our list. We have 6 and 2 are factors of 12. 3 is a factor of 12. We have one more new number we can highlight. What is it? Unmute yourself. Anyone know what new number we have? Ilea?
4.
4 we can highlight.
4.
Ilea, what is 3 times 4?
12.
There you go. So using this first factor pair of 6 and 2, we broke these numbers down to different combinations, and we see we have 6 is a factor, 2 is a factor, 3 and 4 are all factors of 12. Now we're going to do the same thing for letter B. Soren, what can you multiply 5 by to get 30? Soren, what can you multiply 5 by to get 30? Soren, are you there? Unmute yourself. What are you doing?
Nothing. I was.
Oh, you're not.
I
You're
was.
looking somewhere else, and you're not. And I've been calling your name, and you're not responding. What's going on in your room where you're working?
I don't know. I'm sorry.
Yes. What are you looking at over there? What are you playing with? What are you
Nothing.
reading?
Nothing.
What are you? Well, there's got to be something.
Maybe while I was just trying to catch up, while trying to do like more things that maybe
Just
when
stay
I
with me.
was
Okay.
like
Just stay with me.
okay.
I asked you a question that I know you know the answer to multiple times, and you didn't answer. I want you to tell me 5 times what equals 30?
Oh, that is 6.
See, I told you I knew you knew it. So now, Soren, I'm going to highlight what are the factors of 30 in this equation.
Oh, they are. So for the second one.
Nope, I'm on this line. In this box right here, what are my factors of 30?
6 and 5.
Very good. Okay. Bariley with a B, unmute yourself. So Briley, the 5 is just sliding down. We're going to break down the 6 into 3 times what gives you 6?
3 times 2.
Okay, so now Briley, look at your line. Where are the parentheses telling you to do it first?
2 times 3.
equals,
6.
what's 6 times 5?
30.
So Briley, other than 6 and 5, what are new numbers over here that we can now include in our factors of 30? What can I highlight? That's not a 6 or a 5.
2.
There's something else too.
3.
Very good. So now we can add that to our list. Good job. Okay, Peyton, unmute yourself. So Peyton, I have my parentheses now around 3 times 5. What do I need to bring down into this empty spot? Uh-oh. No volume work. There you go.
Now it's working. It wasn't working before, but so what we need to bring in there is we need to put a 2 down.
Okay, so now Peyton, where do we start in this equation?
We
Which is? Riley, help them out. What's 3 times 5? What's 5 times 3?
15,
What's 15 times 2?
30.
Okay, so that works. Riley, is there anything new in this line that we could highlight as a factor? Nope, it's all the same. Okay, Sophia, how do we get the number 15 down here?
Because in the parentheses, 3 times 5 is 15. And
Okay, so that's how
just
we got
moved it
that
down.
number. What goes here?
The 2.
Sophia, what is 2 times 15?
30.
Okay, so Sophia, look at your line. Is there any new numbers that we could highlight as a factor of 30?
15.
Great. All right, very last line. Who knows what 2 times 15 is? Unmute yourself and tell me, anyone?
30.
There you go. So look at all the factors that we found just by breaking up numbers and finding all the different things they can multiply by. So on your exit ticket, it's going to ask you, how does knowing factors of one of the numbers help you? And it gives you specific numbers. I think it's 9. So I'm telling you, the how we did page 1 and these little trees here, though, go back to think to those, because you're going to have to, the hardest part about number 2 is you have to write words. So you have to think about how you would explain it coming out of your mouth and write a couple sentences. We're not only using numbers. That's the hardest part, because I know we're not used to doing a lot of explaining with words in that. So that's what I want you to try to do for number 2 on your exit ticket.